Hi, it's time for another math easy solution. Darren discuss further into calculus with parametric curves and look further into the tangent series, and now look at example 1. And I'll go over part 1 of this example, which is looking at part A of this just because it's pretty long. So in this example, it states a curve C is defined by the parametric equations x equals to t squared and y equals to t cubed minus 3t. And in part A it states, show that C, the curve, has two tangents at the point 3, 0 and find their equations. And remember, the tangents is just a tangent line on, that is basically tangent to the curve or at a point on the curve. And later on in this video series, I'll go over and further into it and sketch the curve. So in the first one, we want to show that there's two tangents, or there's two slopes at this point 3, 0. So part A right here. At the point 3, 0, well, what this means is x is equal to 3. And y is equal to 0. That's just a coordinate there. So at this point, what we could do is solve for t. So from a number, to solve for parametric equations, we need to have a parameter t that at the same time matches the x and y. For example, here 3, 0. Yeah, because we might have multiple t's, and I'll show you that. It will make more sense. So from the equation x is equal to t squared, well, if we plug in 3, we get a 3 equals to t squared. So in this case, if we move this around, t can equal to plus or minus square root 3, because the t is always, when you square it, it always becomes positive. So t is equal to plus or minus square root 3, so the x is always positive in this case. So that's what we have from here. Now we need to see the corresponding matching point from the other one. So from the y equation. So from y is equal to t3 minus t cubed minus 3t. What we end up having now is, if we plug in 0, we have 0 is equal to t cubed minus 3t, and now we can simplify this, just basically take out the t there. So we have a t and then t squared minus 3 right here. So the only way this is equal to 0 is basically because the 0 is there, is either we have t equals to 0, but again, t equals to 0 does not match with this, because here t's, for the x equation, t's can only equal to plus or minus square root 3. So we have t equals to 0, but then here we have, if we set this has to be overall equal to 0, so t squared minus 3 equals to 0. In other words, t squared equals to 3. Move it over. So again, we have here t equals to plus or minus square root 3 right here. Yeah, so this means we have two values of t that align with each other. So then basically at this point we have two parameter values, t equals to minus square root 3 and plus square root 3. Yeah, so thus what we have is two points and two tangents. And basically, two tangents are the same thing. Or two tangent lines, tangents at the point 3, 0. And this is, well, from the parameters from t equals to plus or minus square root 3. So now what we have to do is find the equations of them. So we have to find, the next thing to do is find their equations. So recall that these are just lines. So recall equation of a line. Let's write this down. Equation of a line. So equation of a line is just, y equals 2, I'll put the video in the description below, y equals mx plus b, where this is the slope, like that, and this is just the y-intercept. So when we have it like this, and we know that, I'll put this sign here, at the point 3, 0, what we have is y is equal to 0, so we have 0 equals 2, and I'll just put a line like this to separate from this, recall the equation. So 0 is equal to, m times 3, that's the x value, plus b. So now what we have is the b is, if we rearrange, as b equals to negative m times 3. So that's what this b value is. I just want to write this in a slope because we can determine the slope. So now that we have this, what we end up getting now is, well, the equation is going to be equal to y equals to mx, mx plus b, which is minus m3. Now this equals to, just take the m out, mx minus 3, like that. So that is our equation for a line. Now we just need to know the slope. So recall m is just a slope, which equals to dy over dx. And recall from my earlier video that this is equal to, for a parametric equation, this is just dy over dt over dx over dt. And you can see my last video, I'll put the video link below for the proof of this. So this means is this is going to be equal to the derivative of the parametric equation for the y variable, which is, well, t cubed minus 3t, and then the x is t squared. So this just means d over dt, or the derivative of t cubed minus 3t over the derivative d over dt of t squared, like that. Now what we do is, well, this is the m again, so we can take the derivative. This is equal to the derivative of t cubed is just 3t squared minus 3t, derivative is just 3. And now what we have at the bottom is, well, this 2t, like that. So we could we could end up with this. We'll just leave it like that. So m is equal to this right here. And we could simplify it further. My calculus book does, but I don't know why. It's actually easier to work with this. So now what we have to do is plug in the values. So at t is equal to plus or minus square root 3, and we'll just plug this in with the plus or minus, and because this is easier to deal with. So m is equal to, or the dy over dx, or the slope, equals 2, and now we have 3, and then plus or minus square root 3 squared minus 3. And then the bottom we have 2, and then we have a plus or minus square root 3, like that. And now this plus or minus square root 3, when you square it, it's always positive. So now we can get rid of this plus or minus. That just becomes, well, 3. So this equals to 3 times it by 3 minus here 3, and this right here is just 9. So 3 times 3 is just 9. Over, now we can just move this plus or minus out here. Plus or minus 2 times square root 3. So 9 minus 3 is just 6. So now we have and I'll put this plus or minus in front. So plus or minus 6 over 2, and then we have this, well, square root 3 here, like that. Yeah, because 9 minus 3 is 6, and then again here is just a 2 there, square root 3. And now what I'll do is multiply this by top and bottom by square root 3, and over square root 3. So the reason is this just becomes, this cancels, we'll just get a 3 here. So what we'll end up getting is equals to plus or minus, we have a 6 over 2 like this, times it by 3, and now we have a the square root 3 on top. So now we have a square root 3 like that. And now what happens here is, well, 6 over 2, that's just 3. And then this is, 6 over 2 is just 3. This just goes with 1, 3, and the 3's cancel with this. And what we're left with is equal to, this is just going to be equal to plus or minus square root 3. So that's all we're left with. And this is our m value. This is m. So what that means is we could plug this inside over there. So then now we have two equations. So thus the tangents, thus equations for the tangents, like this, equations for tangents for the tangents at the point at 3, 0 is equal to y is equal to m, which is plus or minus square root 3, and then this is x minus 3, like that. And these are two equations because it's either plus or minus. So that's the solution. And if you think about how the graph looks like, well, if you draw x and y like this, and now if we move over to the coordinate 3, 0, I'll put this like that for the bracket. Let's box this in again. So now that we have that, and then what this means is, let's say at the point 3, 0, so we move over 3, and then the y coordinate is 0. So what we have is a tangent line like this and like this. One of them here is the positive one, y equals to plus square root 3 x minus 3. That's the equation for it. And then the bottom one, or the one that goes down, is y equals to negative square root 3 x minus 3. Yeah, so that's how this looks like. And you can get an idea of how the graph is going to look like. So we have a point like this where we have tangents crisscross each other. And this graph will look, will get more complete as I get further into this video series on this example. Anyways, that's all for today. Hopefully you learned, and yeah, like always, you can download these exact notes in the link below, and yeah, stay tuned for the later parts, which is pretty cool stuff. Anyways, thanks for watching, and stay tuned for another Math Easy solution.